Now in this example, I'll again explain you the most effective technique to solve or to prove trigonometric identities. The technique is multiply and divide by what you want. That is what it is. But it has to be the same number in the numerator and same thing in the denominator. That is what it is. So we have extremely good example here, which is 1 plus sine x plus cos x divided by 1 minus sine x plus cos x equals to 1 plus sine x over cos x. Now, one way could be that you could always write 1 as sine square x plus cos square x and then figure out a way to prove left side equals to right side. But in the test, what you can also do is you can start with the right side, as we'll do now. You can start with the right side, which is 1 plus sine x over cos x, right? What do we want? We want this term, right? And we don't have any clue how to get it. So let us do one thing. Whatever is there in the denominator, let's multiply and divide with that, okay? So that is 1 minus sine x plus cos x over 1 minus sine x plus cos x. You know, ultimately we need these two terms, right? This in denominator, that one in numerator. So let's put at least one of them and then see where we land, right? Hopefully we'll get the left side starting from the right side. So with that optimism, let's multiply, and that this particular technique really works. You will see how. Now don't expand denominator because you need this term. You don't want to cancel that out, right? But expand the numerator, right? So let's multiply these terms. That means 1 plus sine x times 1 minus sine x plus cos x. You should get 6 terms, right? You're multiplying these 2 with these 3. So let's multiply first with 1. So what do you get? 1 times 1 is 1. The same thing. So we'll write 1 minus sine x plus cos x. Now times it with sine x, because sine x times 1 is sine x minus sine square x, and sine x times cos x is plus sine x cos x. And remember, don't expand denominator, right? You need the term which you multiplied with, right? Cos x times 1 minus sine x plus cos x. Correct? Now, simplify numerator. So, can you combine few terms? So we have minus sine x and plus sine x. That could be simplified. And then we have 1 minus sine square x, correct? So 1 minus sine square x is cos square x. So we'll combine these two terms, 1 and minus sine square x, right? So we'll get 1 minus sine square x is cos square x. We'll write cos square x. The next term is plus cos x. And then what we have is sine x cos x. As you can see in the numerator, cos x is common, right? And in denominator, we have cos x, which we do not want. So that gives you a clue, right? So we are very close to our solution. So we can take cos x common from the numerator. We're left with cos x plus 1 plus sine x. And in the denominator, we get cos x times 1 minus sine x plus cos x, correct? Now, since cos x is common in numerator and denominator, you can cancel it out, right? And then what do you get? You get 1 plus sine x plus cos x, which you really want in the numerator, over 1 minus sine x plus cos x. Wow. So that's the way to do it. Do you see that? This is probably the simplest way of proving identities. So apply this technique if you have no other way to get or prove the identities. I hope you love me for that. Thank you and all the best.